All right, can everyone hear me? Ooh, I can hear me. All right. Good evening, everybody. For those of you who didn't meet me last time, my name is Tara Canobio, and I am a member of the K-12 Education Outreach Team and in charge of all 5 CAPE sites. So welcome to the closing ceremony in New York. Glad I could be here. First of all, I think we need to honor those that we're actually here to celebrate. So I wanted to have our CAPE class of 2011 in New York stand up and give them a round of applause. You guys can sit down. I promise I won't make you stand the whole time. No, I just wanted to say it really is because of you guys that we continue to do this program, hopefully year after year. I know I've been talking with the executives who sponsor this, and the feedback has been tremendous, and hopefully you all as parents have heard a little bit about it from each of your students as you come home, and I know we've heard a lot of amazing things. So tonight, it's just going to be kind of an informal program, no PowerPoint presentation on my behalf tonight, going through the rules and regulations. Everyone's made it past that. But really an opportunity to hear from one of our executive sponsors, our main executive sponsor, Stuart Feldman, who is a vice president of engineering. It's going to take a few minutes to kind of talk to you about his thoughts, his vision, and where we're moving forward. And after that, there'll be a chance for the faculty to talk about their wonderful experience and then mix and mingle from that point. So without further ado, I'm going to turn it over to Stu Feldman.
I'll just spend a minute. Hi. This thing? Yes, this thing is. Microphones are always an excitement around here. They usually, but not always, work. I'm delighted to see how many parents have showed up, and the fact that the students have hung in here despite the barrage of what we have handed them and what they've been doing is fantastic. I will take the blame for having started this program a couple of years ago, partly because of a desire to really get exciting things happening. As I've told many people, this is a purely egocentric move. My career began in a program, not quite a design this way, but as similar as you could get, pushing 50 years ago. It's hard to say that, but in the post-Sputnik era, when the United States was actually investing in scientists heavily. And Google, we're just trying our best to do a similar, start some fires among the very best, the most promising of our next generation, get them excited about the next family of science, the next family of technology that will affect their lives. I have a very simple goal here. The nice thing is that, well, yes, we like measuring things, and this is what I'm not going to get measured on. Did we create any of the leaders in the scientific fields of 2040? And that's what I want to see. And I will hope that with a certain amount of simmering and cooking through, yes, guys, sorry, there's another 10 years of school coming, that you will be launched into doing things that I can't even imagine today. And so having the support of their families, having lucky support of Google, we're doing it because we can and we think we should. I had direct support on launching this program and continuing it from the very top. Eric Schmidt, CEO and now non-executive chairman of the company. So yes, we actually do believe in this. I sent him a note last week just telling how things were going, and he was quite happy to hear things are good. So I would be delighted to hear from parents either by email or just at the end about what you've been seeing, any changes, positive or negative. And I'm looking forward, of course, to watching both the scientific demos of what the students have accomplished. I know some things are quite amazing. And then watch you for the next 10 or 20 years. Thank you. Tara.
Thank you, Stu. And I have to say, as a Googler, one of a handful of us that have been in charge of it, working under the guidance of Stu has been a privilege and an honor. I mean, it was his vision, as he said, along with Eric's that came, but really then allowing us to have fun and really kind of bring this to the kids in a way that they can really understand and relate to has been amazing. So probably the next thing I want to talk about before I introduce our faculty is the simple question of what's next. I know that's always the #1 thing that the students start to ask during their last week, and I know the parents are always curious about. So today your students will have received an email from my colleague, Roxana, talking about a program we now call CAPE Alumni. CAPE Alumni was designed to keep the students engaged throughout high school until they get to the university level. So what we've done, we launched it officially in June with the class of 2010, and some of the members of 2010 actually came to visit the class of 2011 this year, is provide opportunities for students to remain interested and engaged. There'll be quarterly newsletters, networking groups, a Facebook group currently that will soon be a Google Plus group as soon as we possibly can. I know everyone's waiting for that moment, so are we. As well as opportunities to come back to Google for workshops, guest speakers. And we really want to, as Stu said, we want to cultivate that next generation of leaders. And we understand that many of the students, unfortunately, due to the nature of education right now, aren't going to necessarily have computer science in the high school. So we want to do everything we can to encourage them along the way. So stay tuned. You guys should be seeing an email today. The parents, you will also receive an email explaining that what we're looking for. But it doesn't end here. So with that, I want to turn it over to two of our faculty, and I know a third one is running around right now, to John Alf and Samuel to talk about the course itself.
Thank you all for coming. I had the privilege of working with another group of students last year, and I can say that we've generated even more excitement this year, and I'm so much happier with some of the students' projects this year. We really got them to a new level. We really changed some of the things, almost in all cases for the better. And I don't have to tell you how excited they are. Hopefully you tell us how excited they are. And I see from my end that I think that most of you guys are going to be happy about it. When we started putting them in little groups, and saw all the scrambling around, trying to learn new things on their own, how to make their projects work, I knew that they were motivated because they had a genuine interest in the projects they were doing. And we told them, you don't have to work at home. And I heard from many of you that they were working at home, and some of them for many hours. So I'm glad to see that that excitement continued at home, and hopefully in the future beyond our program with the CAPE Alumni Program. John?
I'm John Alf Weaver, and one of the other faculty members, and I too was here last year, and I'm really impressed with this group of kids and what they've put together in a short while, because you don't need to hear from us that much. They're going to come up and they're going to talk about how they felt about CAPE, and they're going to show you what they've done for the past week and a half, I would say. They've been working on final projects, and they've really put together some spectacular stuff. And we've helped them, of course, and they also had the help of Google engineers, their mentors, who for an hour a day would come in and take time out of their busy schedule to work with these groups of three and help them out and show them things that we wouldn't have time to, or we hadn't thought of. And so that was very good. Like I said, the program was great, and the kids, I think, really learned a lot. They'll tell us in their own words what they took out of it. I've learned a few things. Lasers are always fun. We have this. We went to a place called Fabbers, which is a automated laser cutting factory, and basically each student drew a little design and then watched as a laser sliced their design into these boxes. And they have been bugging us ever since to take the boxes home, but we wanted to show them all in mass together before dismantling this piece of art that we have. I know a lot more about polyhedra, thanks to some of our students, as well as the flying spaghetti monster, and months more. I've heard from one parent that a student, one of the kids, has requested a giant red bouncy ball for their room. I would ask you all, after seeing them, think about this before agreeing to such a device. But they were great, and the kids were really phenomenal, and I think that they will fulfill Stu's promise, and hopefully, I'll be able to see it, and they'll remember, and maybe one day, they're head of some company somewhere, and they'll be like, hey, I remember that John Alf guy, as I'm sitting teaching high school still. And Yeah, so it's really been wonderful. And Brendan, who was ferrying you guys around, the guy who is not from New York and has probably the worst sense of direction, so we didn't think that through. He's here and he'll say a few things.
Yeah, remember that long walk? I did about 18 times. No, I'm just really proud to be a part of the program. The kids did great, and I really hope that we inspired them to try something else later, and hopefully they won't see anything as being too hard anymore. Because if you can do this, you can do anything.
So the next part that we're very shortly going to hear from everybody and show their projects, but earlier in the course of this program, all the CAPE sites were charged with making a video showing off what is cool about them, and we put together, and we only had a minute, which is actually not that much time at all, and basically, we asked them what they wanted in the video, and they came up with all these great ideas for scenes, and we put them together, and we wanted to show them, show this video to you guys, so that you had an idea, perhaps, of what things looked like. And let's see. There we go. So that was our video, and those ideas came from them. The idea of putting them all in front of one thing and taking the same shot and putting that all together came from them, and I thought that was cool. Also, that sign is by our resident artist, Ryan, who we wanted something pretty, and we just said, Ryan, draw a CAPE sign, and she did it, which was great. So now for the fun part, because, I don't know, we're kind of boring. No. We've got... we have the projects. What?
They agree with you.
They agree, I know. So what we're going to do is we'll call up these are groups of threes, and we'll call them all up. They'll talk about their project a little bit, their experience at CAPE, and we have a little something for them. So there, you guys. So first up, we're going to get Amit Kotekar, Philip Clark, and Riel De Leon to come on up. And they're going to show us their project, Balls and Walls. And someone needs to speak into the microphone.
Hi. For our game, we were inspired by existing physics games, so we just decided we could try a simple one of our own. So basically, for our game, here is the start, basically, and there was the high scores, which we also have. And the premise of the game is to shoot the ball at the red target. And as you can see, there is a wind aspect that can make it hard. There is also a timer.
As you can see, I'm not very good at it.
Yes, we haven't mastered our own game yet.
Yes. Also, there's the time bar implementation, which was fairly difficult to make, seeing as this bar decreases and changes color according to your time. And if I could just get us to pass the first level, you could see the random and erratic generation of obstacles. But maybe later. Why don't you keep trying? Okay, so in an attempt to effectively incorporate our prior knowledge of computer science acquired during our experience here at CAPE, we chose to design our final project, as Riel said, in the form of a basic physics game, appropriately named Balls and Walls, but you haven't seen the walls aspect yet. So the applet required code involving both mathematical, computer science, and physical aspects. And as our group realized that this project was exceedingly more complicated than those we had worked on before, the need for us to divide the components and stages of the game up into small, manageable pieces arose. And though the process was somewhat less satisfying than completing large chunks of the project in one sitting, it was made vastly simpler by the simple measure of divvying up the workload. And instead of having to think about the complexities of programming a ball which forms parabolic arcs, hits randomly appearing obstacles, while attempting to avoid erratic other types of distractions, and then beating a time limit all at once, we merely tackled each component of the program, such as gravity, collision detection, speed of the ball, in an isolated and thereby successful manner.
We faced a lot of challenges in building this game. As you can see, one of the challenges is wind, and not just playing the game, but making it actually work towards building the wind. We also had a very hard time doing the drag code for setting the speed of the ball and forming a line. Congratulations, Philip. So we also had trouble with the drag code. There was also the timer, because we used a lot of the reference on the website, the processing website, which is the programming language that this game is built out of. It was out of milliseconds, so we had to find a way that we could turn it into seconds, and that was kind of hard. The timer bar was also hard because it was constantly changing with an increasing time. And the most difficult thing that we had trouble with was the line collision, because it is not as easy as two circles or ellipses colliding together, where you could just test if the radiuses are near each other. But the line collision was much more difficult, and our mentor, Jason, really helped us out with that. Thank you. Our pause button was another challenge. We had different screens. If you notice, we had a menu screen, and yeah.
Good job. Thank you. All right. Excellent. All right, so let me just, we did not coach them on what to say. They seem to have lots of interesting things to say, which is not surprising to me, but they're coming up with this on their own. So next up is Benedict Bolton, Ryan Tam, and Jacob Bajor. No? Joseph Bajor, Jacob Friedman, sorry. I never called them by their last names, and I thought I had got them all, but...
You really tried working for the presentation to memorize the whole last name?
I did. There you go.
Okay, so our game is based off of a web game called Hungry Sumo, and the point of the game and our game is to destroy all the enemy balls on the screen, those red balls. There's also music, but it's not on right now. And also the resolution is messing it up. Yeah, but yeah. And so you increase, if you mouse over the ball like Benedict is doing, then the ball gets bigger, and the size of the ball corresponds with the decreasing of the balls. So you go.
In the game, we programmed 10 levels, with each increasing in one ball at a time. And when I beat this last ball, you can see that we also added in every 2 levels. For the first 4 levels, there is a harder ball that's added, this cyan-colored one. Yeah. And that cyan ball does, instead of 9% of the radius to decrease, your ball's radius, it does it does 2 times as much. So you shrink 2 times as much. We also had to make the collisions for each of the balls to check one against all the others, which caused some difficulties Ryan's going to talk about. And yeah, the game can get very difficult.
So we haven't really gotten past the 2nd level yet, but okay, well, Benedict got to the 3rd level, but we had quite a couple problems. One of them was definitely coding it, because we had issues with the spawning of the balls, which is when instead of the balls colliding and like moving apart, they stuck together and kind of moved around with each other. And so also we had trouble with the levels, because we had to make double for loops, which is where you have a for loop inside another for loop. Another problem we had was ball collision, as he said, because we would have to learn about vectors, which was part of the language that we hadn't taught, that we weren't taught yet. And we would also have to use trigonometry, which would complicate things.
So luckily, we want to say thank you to Sam, who gave us a very nice, simple code to solve it. So, we also just wanted to say a few things about CAPE that really made us enjoy it. I just wanted to say that to Google in general, for any Google employees here, you fed us very well, and I'm very happy for that. Having sea bass over risotto and squash and a nice summer salad was delicious. And also, this program really opened me up to computer science. I was not much of a computers person before, but made me much better.
Yeah, the program was really creative. I really liked it. It brought out all our creativity with all of the languages that we learned, and just it was really fun.
So I didn't know anything about computer science until I came here, and I'm really glad I came to CAPE, because it was a lot of fun, especially since we got to have 3 amazing teachers these past 3-4 weeks. And yeah, it was a lot of fun.
And I thought they didn't like us. All right, so up.
Yeah.
All right.
And we, once again, did not coach them on what to say.
Yeah.
Nothing.
Yeah. All right. Well, that's different. So next up, we have Abby Fremo and Sarah Barkley. Sorry, Sarah. And they will come up and. There you go. Start it up.
Oh, we have to share? Okay. No, okay. You guys like each other. We do. Okay. Okay. So, so should we show it first? Okay. So this is our game. All right, ready? It has music too. Okay. So this is a game off of the original game Doodle Jump. And you have to.
Yeah, sure. So what Abby said, basically, it's a variation of this basically Apple Market game called a Doodle Jump, where you basically have to jump on the paddles and try not to fall down. So one complication we had during this game was definitely the bouncing, because we had to bounce out the distance that the doodle was moving, in addition with the speed that it was moving, so it'd be kind of realistic. Another problem we had was definitely moving the paddles, making the paddles move down and then restart back up, because we only have 15 paddles, but they basically have to go on forever or for a long amount of time. So we had to work on getting it to go back to the top for all the paddles, yeah. And So during the game, we have different backgrounds that you can change when you press a key. So like, we have just kind of to add a feature to the game that we added on later after we got the basic game working. And our mentor, Igor, he helped us a ton, and we would have been nowhere basically without him. So thank you very much. And yeah, so like another very difficult thing in programming in general that a lot of programmers find challenging is the debugging, which is basically when you go through the whole program and you look for all the mistakes that are wrong with the syntax in your code. And we definitely found that quite annoying because we had to look through like each line of code and make sure that it would work properly multiple times. So it wasn't the best. And do you want to talk about Cape or whatever?
Yeah, so here, hold on, we'll let it die. And he disappeared. All right, so just to say something about Cape, it was an amazing opportunity to come, work at Google. It's very, very, very cool. And besides like the amazing food, it's just all the opportunities to see like the guest speakers and have like, the person who created Java and Python. It was just very, very cool, and all the activities, very fun.
As you can tell, Abby was very excited about it. One thing that I found very interesting about this program that I have taken one other, it wasn't really computer science, but it was like robotics portion of it. And what I found was very interesting about this program was that it was 4 weeks is a long time, but it was only 4 weeks in a way. And like how we went from, like I went from no code, like knowing no code whatsoever, no programming languages, to being able to program a game in like processing, which is this language. I just thought it was really amazing, and that our teachers, though we give them a very hard time, were really incredible. And I think that this program, they definitely should continue this program as they're going to do. And I just think it's really great and opens our eyes to the possibilities of programming. And
thank you. You just put it down. Hold on. You've got. All right. Apparently, I'm doing this. Wait, don't go anywhere. Yes, Abby, that's yours. You guys get certificates because you did something cool. All righty. So next up, we have this project. This is, what do we have here? Whose is this? Arnab Banerjee and David Wong and Dylan Azam. Come on up. Who's here? There you go.
All right, so our game's name was Dog of War. Sadly enough, we didn't have enough time to program the dogs into the game.
But it still works.
It still works. It's just missing the dogs. Okay.
Should I play in you?
Yeah. Okay. At the top of the screen, there's a health bar, and when you hit a cat, it squeals, yells. There's also the level, and there's upgrades. At the top, the fireball is in red. It means you can upgrade it, and you can buy more as you buy fireball, and then you can unlock thunderball. Basically, the game revolves around a war between cats and dogs. You're on the dog side. The cats will try to break down your wall, which is the red rectangle, and if you fail, then you lose. If you fail to protect your wall, you lose. I'll hand this over to Arnav, who will talk about the challenges we faced.
Okay, so there were a lot of elements involved in creating this game. We had to figure out how to simulate gravity. We had to program it to understand when the ball was hitting the cats, and all of this took a while. Another big problem was when things just wouldn't plain work, and that was, of course, the debugging that Sarah was talking about, and that was very difficult, especially when you don't even know what you're looking for. But I think as a team, we managed to overcome all those problems by working together, trying to delegate like portions of the project to each person so that we could get a lot more done than just one person working on it at once. And also a huge help was our engineer, Steven. We owe a lot to him for helping us put this together. And of course also to our instructors for teaching us everything that we used to create this.
Yeah, this project really progressed a lot since we first started. It originally started as a simple gravity situation. We had pretty much no idea what we were gonna do with the gravity, but we wanted to make gravity. And then we combined it with bouncing, just to make a cool little bouncing ball that falls. We eventually, after a lot of annoying coding, figured out how to make a slingshot. And after going through many ideas, including angry pigs, where we would either build and then defend against the birds or shoot pigs at the birds. That never worked out, and eventually we came up with this, which, yeah.
Thank you.
Thank you. Hey, don't go anywhere. Oh, no?
You guys didn't talk about it.
There you go. All right. I'm glad they listened to me and implemented a mute feature on the cat meowing. That was fun all day. Meow, meow. All right. So next up, yes, this is it. We have Zachary Buttenweiser, Kevin Becker, and your third was Aaron Zhang. Come on up. And they're going to show us something that's not a game.
Okay.
I'll take these. Sorry,
This program is just that, not a game. We wanted to make something that could be actually used in real life to help solve problems with the use of software engineering and computer programs. So we decided to make a predator-prey model, which Aaron will tell you about.
Okay, so imagine you're a farmer. Your rabbits keep on dying because these foxes keep on eating your rabbits. So what do? Well, we created a program to simulate the interaction between rabbits and foxes. And what? Excuse me, fox eye. But so we, rather like all the other groups who actually made a game, we made a simulation that showed the interaction between foxes and rabbits. And these foxes could breed, these rabbits could also breed. And as time went on, the foxes would eat the rabbits. The foxes and rabbits would eventually die out if they didn't have any health. And I guess Zach will show you more about it.
So you can set the number of rabbits that you have as well as the number of foxes with 2 easy clicks. So if anybody in the audience wants to pick a number. What? 42. Okay. And another number? 3. Okay, so I'm gonna make 42 rabbits and 3 foxes. Here. You sure? Okay, so let's run this simulation and watch what happens. we added some neat features like the foxes eat the rabbits and the rabbits make more rabbits. And we also added the ability to pause the simulation and hide and show the health bars on the rabbits and the foxes. So now we get data for each of the foxes we can see which foxes have eaten the most rabbits. But now that the rabbits have died out, the foxes have nothing to eat. So while a couple more will breed a couple more foxes, the foxes will eventually all die out from starvation. So rabbits can die from old age, and foxes can die from starvation. In this way, we make it even more realistic to a real-life scenario. Another way we tried to make it realistic was by implementing different variables for each fox and rabbit. We did some research and found what a predator needs to track its prey, which is right here. Speed, stealth, camouflage, and we implemented those with variables in the fox's class. We also found that prey need camouflage to hide from the predator. In this case, we implemented speed, stealth, stamina, and the ability to have some sort of poison or thorns to basically keep the predators away. Now, we had a lot of difficulty in this program, and Kevin's going to tell you what we had to solve.
As with most programs, there were a lot of bugs. Like there was a really weird glitch. Since the foxes were designed to follow the nearest rabbit at all times, sometimes one rabbit would get closer, and so it would twitch back and forth between rabbits, which was not realistic for our simulation.
It was actually an error in the processing language, which Kevin and Aaron figured out how to fix. Along with Pepper. Where's our mentor? Pepper, is he here?
No, he couldn't.
Big thanks to Pepper. He helped us so much.
And we also had problems with making more rabbits. Like it picks a random number, which determines the probability that it can have that another rabbit will spawn. So sometimes you would have exponentially, like just a rabbit reproducing over and over again. And so we had to implement a population count, so a cap, so that you can't have this, you can't go over a certain amount of rabbits, so that that your program actually ends. And that's really it.
All right. You guys done?
No, I just have some words about Google.
Oh,
yeah.
quick.
Okay, so the one thing I really wanted to point out, I don't think anyone said it about, the best part was definitely the free stuff for me. I'm a sucker for free stuff, so when they gave me the bag the first day, I pretty much died of happiness. And yeah, so I mean, it's a really great opportunity, and I came into this program not knowing much about computer science, and I still don't know much about computer science, but I mean, I've learned a lot from the past few weeks, and I really want to thank everyone here for the great opportunity. So,
thank you. We got it. All right, thank you. And just to see, they really Sam's not quite right. We did coach them a little bit. We told them not to thank us too much for the food and not to show their code too much, so it shows what they listen to. So next up, we have Natan Zamansky, Chris Pardee, and Arjun Mithal. If you could come on up. Someone take a microphone.
Hello.
Okay, yeah. Okay. Hang on. So this sprang from a couple of ideas we had. It's sort of a cross between ideas. I had an idea of a life simulation, not like what they just did, but more like a social interaction thing. Chris wanted a game aspect. Chris can talk about that. Yeah.
Okay, so I was playing. Oh, thank you. Okay. So I was I was playing. It's sort of like a cross between a life simulator and like Space Invaders, and I'm a video gamer. I'm working on a video game. I thought it'd be cool to make one using code, which I've never done before, and so I was really biased towards having a game. So we merged the two ideas into something that's actually really awesome, and I'm very proud of it. So Arjun is going to play the game.
Yes. We're not up to the demo yet. We want to build suspense. Okay. We want to get them really excited. Okay. Okay.
Remember, you only have
so
5 minutes.
They, the game works with, there are a bunch of smiley faces, and they interact. And they interact on 3 levels of AI. They have friendliness, which is the main aspect to the game. They have persistence, which is how well they can convert other blobs to their level of friendliness. Smiley faces, not blobs, sorry.
Frowny faces.
The original
Yeah,
blobs.
they were originally blobs. And intelligence, intelligent, unfriendly faces will actively seek out the friendly faces, and vice versa. So, Arjun?
And the strength is based on their size.
All right, right.
Oh, go to the main screen.
Wait, yeah, go to the main screen. Chris did all of the awesome art.
Thank you very much.
Read the screen, read the screen.
So we called it Smiley Factory because we made up this little story that there's a malfunction in the Smiley Factory, now producing frowny faces. Oh no! So you have to protect the smileys from the frowny faces. So
Go.
Yeah.
Go, press any key to begin. Good. So he's, you can see he's shooting at the frowny faces. If you shoot a smiley face, you lose a life. The levels get progressively more difficult. There are a lot more blobs on the later levels. Smiley faces, sorry. What's coming down there is a power-up. That is a smart bullet. The smart bullet goes after unfriendly blobs.
And it missed.
And it does miss a lot, but it does go after them.
It's guided to it.
Yeah.
Do they all turn unfriendly?
Yeah.
Oh man, no points.
No, there's an 89-point bonus.
Oh, okay. Then.
They're all unfriendly again. And apathetic. Apathetic. Don't forget the
Apathetic is the
apathetics.
face that over there. Kind of right in the middle.
One of those power-ups, the pink one, is a hope missile.
Oh, this is
makes it makes faces friendlier. Woo!
You switch
Oh,
power.
you got the smart bullet.
The hope missile, it shoots the blobs or smiley faces. I'm sorry, and it explodes, and whoever gets hit by the explosion becomes more friendly. And it's actually, it adds kind of a level of strategy to the game. You want to get the power-ups so you can sort of sway it in a certain direction.
You get more points for more friendly. Use the hope missile.
Yeah.
Woo.
The points are. Is it the values of
It's
their
the
friendliness?
value of their friendliness.
Yeah. So yeah, see, he just made that dark purple one bright pink. Now he's happy. Happiness is good.
Laser. The laser. The laser penetrates an entire column of blobs. It is kind of dangerous because you'll hit a lot of friendly blobs, but
Do you want to
it's worth it.
skip to like level 9 or 10?
10.
You could turn off the program.
Yeah. And
No, not 11. That's the boss.
10 and set the score up.
Hacks.
Okay.
We can hack it. It's our game.
Yeah. See, there are a lot more blobs here. Faces. Blobs. The darker they are, the more unfriendly they are.
It's based on red, green, and blue values. Natan can tell you that. I don't
The
exactly
friendliness
remember.
is in the red value of their color. Their intelligence is the green value, and their persistence is the blue value. So it's really the cyan ones that you have to look out for.
This game was really a lot of fun to make, and we can. Oh yeah, so this is
here's the final
the
boss.
final boss.
Chris explains that.
Yeah. Okay. So,
Fight it.
originally my idea for the game was just, my friend Dylan and I were working on this whack-a-mole final boss, and everyone's like, "How do you do that? It's just whack-a-mole." And so I was joking about an out-of-context final boss. And so we sort of as we combine the ideas, this final boss emerged. It's a pretty awesome-looking rectangle. And it spawns unfriendly blobs, and are you shooting the friendlies?
Well, they're not doing so well.
You can shoot the friendlies at the boss, and
friendly blobs start to lower the boss's health.
we're kind of bad.
Yeah. Now. Okay. Yes.
Yeah, the game's really addictive, actually.
Okay.
We kept procrastinating because we were having too much fun, which is kind of good, because then...
And it's really
thank you.
difficult to... it was really difficult to debug because we have a lot of code here.
Oh my god, yeah.
Yeah. And one of our biggest problems was in the collision. A lot of times, well, I tinkered with it a lot, but either way, like, once they touched each other, they just wouldn't let go. And we had to fix that. It was a bit of a problem. Also, yeah.
Okay. I guess I'll give a few words to
Yeah.
Google Cape. Should I? Or
Yeah,
am I being pushed off stage? Or?
No, it's not like that.
Okay, so Google Cape has definitely been a great experience. It was a lot of fun. I learned a whole lot. And what kind of, like, when do you get to be with a company like Google and you're not even in high school? You know, like, that never happens, except it did. So this was just a wonderful experience. I've definitely learned a lot. I made a lot of new friends, and hopefully I'll take these experiences with me, and I actually will. Why did I say hopefully? Yeah, it was just a great experience.
Yeah.
Thank you very much, guys.
Thank you.
Don't forget. All right. Excellent. And we also learned that Arjun is a perfectionist, and we didn't realize that until today. All right. Next up, we have Andrew Millick, Cyrus Riza, and Aaron Mortensen. Come on up.
Okay. So we have a little.
Hello.
We have a little PowerPoint first, and then we'll show you our game. No, it's right there.
Oh, my bad.
Yeah. Okay, so it's very short, and then. So, do you want to talk about it?
Okay. All right. Well, we have a first-person shooter, which people, I don't know, normal people would think of like as something like Call of Duty. We credit the name to Sam. It used to be a pretty bad name. Now it's all right. So yeah. Okay. So in the first slide, you can tell that's in our game we have a hallway full of targets that are
in 3 dimensions.
Yeah, it's 3D, so it was really hard to make. It's a hallway filled with boxes that are red, and when you shoot them, they turn green. And so yeah, it was. Well, that's the hallway. That's like when we say alpha, it's like that was how it was.
The first stage of.
Yeah, it's pretty
production.
basic, and that's our renderer. A renderer. Well, that's what's possible to make with our renderer.
We didn't make that though.
Yeah, so it's pretty similar as you can see. Yeah, keep going.
Okay. So. Here.
No, let's go ahead.
No, go. I'll do the next one.
Oh, no, it's fine.
Okay. Here's a screenshot of our game. Was this morning. And it's changed a little, but as you can see, you shoot the boxes and they turn green. So keep going. This is our last slide. So we were trying to do collision detection with just if you're in front of the box and you shoot it, it turns green. But it was really fake and it didn't look so good. So we tried to use, upon the suggestion of our mentor, or one of them, vectors. And this little formula tells you the distance from a line to a point in 3D. So that's what we ultimately use to detect if you're shooting a box or not. Okay, so.
Yeah, so the first problem we had really with making a program in 3D is At first, the renderer that they have built in with processing didn't really work. Instead, when we wrote box, instead of getting a box, we got a weird triangular shape with lines coming out of it. So we had to find a different renderer, and that kind of got us caught up for a while. But once we got over that, it was a lot
Okay, so we'll show you our
easier
game.
and- Yeah.
All right. Okay, so it's a first-person shooter, kind of like Call of Duty, and you shoot the red boxes. So we made like a site, and we've got some music. It's pretty good.
Sorry, we've been having some display issues on the big screen.
If you've seen Chariots of Fire, it's the theme song.
Okay, I need to turn the sound down. It gets kind of loud. So I can move around. I can move around this little hallway, but if I try and get out, it'll not let me get out. And so let's shoot something. So you can shoot something that's right in like you're part of, but if you're in front of it, you can shoot it. So you see they turn green. And the ammo count, as you can see on the bottom, is actually twice the original number of boxes, which now move across the screen. And you can zoom in and stuff like that. So it's quite an enjoyable game, but often not so satisfying. Oh, and one more little thing. If you're a little far from box, the accuracy of your gun goes down. It's sort of realistic, I guess. So that's pretty much it. And we really enjoyed making it, although the 3D in the beginning was quite a challenge. And we couldn't actually just use processing as its own entity. We had to download a couple libraries that added more intuitive control of like the camera and other things. So let's talk about
So
Cape.
instead of just being able to move the camera back and forth on an X and Y axis, you could actually rotate the camera and move it different ways, like diagonally.
All right. We'd really like to thank our mentor, Gideon, who I don't think is here because he's got work since he works at Google. We couldn't have done it without him, and he gave us a lot of good advice that helped our project. I'd also like to thank Google for letting us be here.
So it's been an honor to work, or not really work, but work on our projects here. And it's not just a computer science class with one teacher and a bunch of kids. It's 3 teachers and the same amount of kids in Google. So it was quite an incredible experience, and I'm privileged to have been here.
I also enjoyed CAPE, especially because of really the structure of how we learn things. Instead of just sitting down all day learning things, although we were sitting down for a lot of the day, we were taught one thing in like a short lesson and then basically allowed periods of time to work with it and play with whatever command they had just taught us and see what we could do with it. And often I found myself working into the breaks a lot of the time, which annoyed me when I realized it was a break and I was wasting the time that I really should be bouncing on red balls, but I was writing code instead.
Hey, we're not done. I think the one of the best parts about being here is we actually got to video chat with some awesome people like the inventors of Python and Java, which I think was pretty cool, but no one really made a big deal out of that, which was surprising. We also got to see Michio Kaku's lecture to the actual Googlers, which was very cool.
So thanks to our teachers, our mentor, and the guest speakers, and the people who hosted our trips. It was all very enjoyable. Thanks.
Cheers. All right. Yeah, we tried to trick them into actually doing work when they didn't have to. So our last group here, we have Jeremiah Milbauer, Joseph Bajor, and Aaron Polyhedra Zhang.
Both of these work, or?
Yes.
Yeah. Okay. Cool. So I'm Jeremiah Milbauer.
I'm Joseph Bajer.
And I'm Aaron Zane, polyhedro.
Because we have two Aaron Zangs. Oh, we should probably open it, yeah. Hey, you can start talking.
Okay, so our game was called the Polyhedra game because it was based off another project I made in BYOB, a different programming language, build your own blocks. And it's an improvement because in this language processing, there's more functionality and a lot less lag and cool effects like the tail behind it. Yeah, it was called the Polyhedra game because in my other version we were controlling and yeah, we were controlling a polyhedron instead of circle as we have here. But if we had more time, we would have liked to turn that into a polyhedron.
So when we were, is this working? When we were designing our game, we met with a lot of challenges because I don't think either of us, any of us, had really worked with a programming language as complex as processing before. So one of the challenges, probably the most important part of the game, was getting the circle to move around when you use the arrow keys.
And we overcame that challenge by actually making the up, down, left, and right arrow keys binded to a Boolean, which was basically a true or false statement. So for instance, if you press up, then the up Boolean is set to true, and everything else is set to false. So your ball thing starts moving up.
Another challenge was figuring out how to get the ball to sense when he captured a treasure, which are the blue things, or when he bumped into one of the enemies.
Which you're not supposed to do.
You're not supposed to do it, but, you know, for purposes of demonstration. But we overcame that by...
We actually, because we have a variable in each class which is what everything's made of. Each separate treasure or character is put in a class or enemy. And we have a variable which is a radius. And basically when two things collide, we add up the two radiuses and see if that's greater than the distance between them.
Another thing we had to do was, as you can see, this blue ball, he follows you. And we accomplished that by, if you look in his code, which we're not going to make you do, he sets his position to what your position was a little while ago. However, Aaron came up with this great idea where his position is actually a little bit off from your old one, so he can't, be too hard, right?
Yes, because otherwise you would lose.
Like I tend to do.
Right.
Yeah.
And as you can see, there's now a gray ball, a gray circle on the screen which grows and shrinks and moves in a pattern, so it's sort of harder than the red one. And the black one's bouncing around, which we added also. So basically, as you, the more points you have and the higher level you're at, then the harder the balls that are.
Right, and that was another challenge, figuring out how to get the level system working. We did that by every time you capture a blue square, you can see here your score goes up, and every time your score is equal to your level squared, your level will gain 1. So when I get this next box, I will level up because 2 squared is 4, right? And so the reason we did that is because in most games, as you progress, the levels get harder. So we had to. Harder. It got too hard. We had to figure out a way to make the difficulty actually scale. We had plans for even more enemies, like a green one that shoots, and I think Joseph wants to talk about that.
I was in charge of making the green one, which ultimately failed in the end because it was probably the hardest one. I had to make it shoot 3 smaller red enemies that actually fanned out across the screen. Now, I got them to fan out, but every time it hit a corner of the wall, it would shoot them into the wall, which kind of defeated the purpose of it.
Yeah, another thing we would have we were working on is where is it? Is diagonal movement, and Sam helped us with that. And what you have to do is you have to use the Booleans like we did for the arrow key movement. However, you have to also do statements whether if you're moving right and up, it'll move diagonally to, I guess, for you that way. No, it was that way. All right.
And other improvements that we could have added are like, for example, a live system, so you don't die as soon as you hit one of the circles. And yeah, we were trying to add 3D also, which would have looked cool.
Oh, okay. So we're done. But I just want to say that CAPE was a really, really awesome experience, and for a lot of people who, like me, hadn't had much experience with computer programming, it really gave us an opportunity to look into that world and gain a love for something we had never experienced before.
And we almost went the whole way without getting anyone injured, and then we almost lost Joseph there. But no. No, it's okay. Let it be. Let it be. You fixed it. Yay. So that was the work that everyone, that the students put together, and I mean, really amazing stuff. And I just want to mention, Aaron Mortensen mentioned this, that we'd given them an assignment, and then we gave them time to, we do a little lesson. This is how you do this one thing, and really, almost all of them after that, they would try to code it, and they would often go much further than what we had intended them to do, never listening to us. So that was really wonderful to see, and these projects are all an example of them really going much further than we had taught them. They really did a lot of great work, and some of you may have been like, oh, these are cute games, but there's a lot that goes into all of these, and really impressed with that. With that, we're pretty much done. I'd just like to, thank the other two instructors. They can come on. I mean, Brandon and Sam, they were great. Tara for putting, organizing this across 5 sites, and that's crazy. We've got our mentors. There are a couple mentors who are here, and they were really instrumental in helping us. We have Zuri Kemp and Aaron Mindell, who really made sure that we actually got all the things we needed and went on our trips. And of course, Stu Feldman, who really, without him, we wouldn't have had this, so thank you. And is there anything you should say? All right.
So with that, it's now time to just really celebrate. We'll turn the music back on. We have a great spread in the back. We're all going to be here to hang out. So if you have any questions, you needed anything else, please let us know. And Stu wants to do one final remark.
So first of all, I'm absolutely blown away by the projects. For those of you who have never programmed or have forgotten high school or college physics, the amount of mathematics, the amount of programming that was actually buried in those is absolutely extraordinary. Sorry guys, you learned the first lesson of programming. It never works the first or second time, and it breaks all by itself. Debugging is like that. Congratulations, you actually got it to work. And I'm really absolutely amazed what you accomplished. Let me give my special thanks to the teachers who've absolutely done an amazing job. And I frequently bump into them in the cafeteria at 8 p.m., recovering from and preparing for the next day. So thank you, amazing, and all the staff, Tara and friends, thanks an awful lot for actually making it work. And my thanks actually for the Google volunteers who spent time mentoring. And I don't remember who said it, but I heard one of the best characterizations of life at Google ever from one of you. I wasted the time that I could have spent bouncing on a red ball by coding. That is perhaps the best description I've heard of engineering at Google. Thank you.